morning, grade 5s. Happy Tuesday. So we have officially moved on to our second last unit of math. We've got this one and we've got a tiny little baby one at the end. So this one is Introduction to Geometry. Yesterday you had a chance to just kind of get a nice little warm up, familiarize yourself with looking at different shapes, looking at side, faces, vertices. Today that's what we're going to go over, which are things that you've learned in grade 4. Should not be brand new. If it is, then you've got to make sure you're really paying attention today, okay? So all you're going to need for today's lesson is your math notebook, pencil, highlighter. We'll grab that, and as always, write down the date, the title, which is Introduction to Geometry, and then our I can statement is I can use attributes, and then I'll talk about what that means. I'll talk about what attributes are in a moment, but I can use attributes to describe shapes. And then please highlight that. So I can use attributes to describe shape. We're going to be looking at three to four, mainly three major ones, and then kind of like a fourth one, different attributes to describe shapes. Now what attributes basically means, and I'm going to talk about it in a second too, but is just different information. So instead of me just saying, here's a shape, it's a fun shape, you describe it in many, many different ways, and there's 3 to 4 major ways to describe any form of shape. So let me just put a little pointer. So attributes, and actually I'll write this in the other marker so it stands out. Are just using different ways to describe a shape to help identify it. To identify it. So let me read that. Attributes are basically using different ways to describe a shape to help identify it, because obviously we know there's tons of different types of shapes, right? And instead of me just saying this is a square, this is a rectangle, and of course that's fine, but for someone who's never seen a rectangle, who's never seen a triangle, who's forgotten what a triangle or rectangle looks like, the reason we have these attributes are using different ways and saying, well, a square is this because it has this many sides, this many faces, this many vertices, and then you're like, yes, that must be it. So it helps us identify what they are. But just a fancy word to say different things. Yeah, really. Instead of just saying things, it's a fancy word to say different information explaining a shape. Okay? So write that down, and then pause this video if you need to, and I'm going to erase this, and then we're going to go on to learn those 4 different attributes. Okay. And like I said, most of them you'll know. You should know all of them. So the first one is length of sides. So the length of the sides is your first attribute. It's the first way to explain a shape. So let me get this. If I have, and this should be familiar to you because we talked about shapes when we did volume. We've talked about looking at area and perimeter. So it's kind of related. This topic is kind of related to that unit as well. So hopefully you have a little bit memory of that too. So if I have a rectangle, which we should all know what that looks like, and in your mind, when I said rectangle and you thought of a shape, the reason that that shape popped up in your mind is because, one, you're so used to it, but right away, you probably thought of something like this. Hopefully, I'm hoping that when I said rectangle and you saw me about to draw, you thought of something like this in your mind. Because you know in your mind that's a rectangle. But what makes this a rectangle and not this? And that's why we need attributes. So what? So if I told you this is a rectangle and this is a square, you would say, yes, of course that is, right? Because, why, right? I can't, that's not a rectangle. But why? What if I came and said to you today, that's a rectangle and that's a square? And you would say, no, Miss Mavish, you're wrong, because why? And that's what we're looking at today. So we know, we know that this is a rectangle because there's always, and that's what we're talking about, the length, because two sides are always the same, and these two sides are always the same, right? And then we know for a square, what do we know about the length of a square? Do you remember? The length of a square is always the same. So for example, and let me pause here for a second. Let me talk about when we were doing shapes in I think 2 units ago. So if I know this is a rectangle, we know if this is 7 meters, this also has to be 7 meters. If this is 2 meters, we also know this has to be 2 meters. Does that sound familiar? Hopefully that does. There's no way. We did a unit test on this, right? So I know that if this is 7, this has to be 7. If this is 7, this has to be 7. That is the first attribute of a rectangle, right? Now, instead of me putting this, and I'm not gonna, that's why I just did that as an example. I don't want these numbers. Now let's say I don't know how long, maybe I don't know how many, for example, I want to measure this, but I don't have a ruler. I don't know if it's 7 meters or 7 centimeters or 20 centimeters, but what I do know is that this length has to be the same as this length. And I can identify that attribute by putting little dashes. Let me explain what these dashes. So I'm going to put 1 dash here and 1 dash here. Now these dashes, and you've probably seen them in your math textbook or maybe in your classes, this just represents that every time, anywhere, anytime in this shape I see this 1 dash, that means they have to be the same. Anytime I see 2 dashes, they have to be the same. So for example, here, I'm going to put 1 dash here and here, and here and here, because they're all the same. So I know this is 5 centimeters, these are all 5 centimeters. Or I could also, if I put 2 dashes, I always have to put 2 dashes. It's basically a symbol. It's instead of me writing, because in math, we always like to simplify things, right? In math, we're trying to get away from words. So in math, you use symbols and letters and variables. So these symbols represent, tells me right away that the lengths of these sides are the same, they're equal. It doesn't matter if I use 1 or 2, but it just tells me. So in this case I use 2, in this case I use 1, because these two have to be the same, and these two have to be the same. I can't do this, and you can probably tell me why in your mind. I can't do this, because what does that tell me? So if I put that tells me, oh, this length is not the same as this. These two this tells me right now that this, and this side are equal. And that's not true. We know that about a rectangle, right? We know that these two are the same, but we know these two have to be identical, right? So again, I'm just saying that these dashes represent, they're a symbol to tell us which sides are the same length, okay? And that's what the first attribute is. And I'm gonna write this down. So, remember, so please write this down. Remember, and I'll put them, maybe I'll put like dashes here. So dashes like this, or dashes like that, or maybe I want any dashes, whatever form of symbol you're using are, these are, and the mathematical word for these are hatch marks. So I'm going to write that a different color so they stand out. These hatch, H-A-T-C-H, marks, yeah, shows that Okay, let me read that. It says, remember, these hatch marks, can you see that? These hatch marks show that the length of the sides are the same. So again, just to recap, as soon as I see this one hatch mark, a little dash, tells me anywhere I see them, they are equal. These are equal. In a square, we know that these are equal. If I have, let's do another example. If I had, I'll do it down here. If I had a triangle, a perfect triangle. If you know a triangle, you know that a triangle always has to have equal. This one, for example, this happens to be 3 equal triangles. Maybe I did a very wonky triangle, and I went like, maybe I went kind of wide, much wider. And maybe when I use my ruler, right, none of them were the same. Maybe this one is something else, this one is something else, and this one is something else. That's okay, because sometimes triangles are like that, right? Sometimes triangle sides are all equal, right? They might be 4 centimeters, 4 centimeters, 4 centimeters. But as soon as maybe this one is 5, and maybe this is 8, and maybe this is 7, they're all different, then I have 1 hash mark, 2 hash mark, 3 hash marks. It just tells me that the lengths are similar or they're different. Okay, that's the first attribute, length of sides. Okay, pause the video here, and then I'm going to erase it, and then we're going to move on to the second one. Okay, so the first one is just looking at the length, what the measurement of this length is. The second one we look at, this one's always easier, number of sides. So as long as you can count, this one is super easy. The number of sides. So, for example, let me draw some shapes. If I had a shape like this, so right away you should know that's a triangle. Oops. Here, at a moment. I know that this is a 1, this is a 2, this is a 3, so that has 3 sides. Right? Easy enough. If I had, maybe I have, we're going to look at, and tomorrow we're going to look at all the different types of shapes to see if you remember. But this time, and I'm going to say 1, 2, 3, 4, 5, 6. This has 6 sides. So this one's super easy, right? You literally just count the sides. Depends on how many sides there are, but that you just count the different sides. Now tomorrow we're going to quickly look at what the different types of shapes are based on the number of sides, right? So maybe I'll quickly mention them here. Do you remember that if I have 3 sides, I have a triangle? So you know it's a triangle, but the root word of triangle, T-R-I, means 3. That's 3. If I have 4, like I said, I'm going to do this tomorrow, but I'm going to quickly just mention it. It's, we can say, or what did I have here? I had 6. So 6 is a hexagon. Oops. Holy moly. Hexagon. Because hexagon. So we're going to look at this tomorrow, but their root words mean how many sides there are. So a triangle, maybe you knew this before, maybe you didn't. The tri, T-R-I, means 3. In English, tri means 3. Like right when I say get into a duo, that means 2. Getting to a tri, that means 3. Hexagon, H-E-X-A, hexa means 6. Right? That's why this is a hexagon. This is a triangle. So we'll do that tomorrow, but today I just want to talk about number of sides. So today's just focus on the number of sides, which all you do is you just count the sides, right? That's probably the easiest attribute to say. Square has 4 sides. A pentagon has 5 sides. A hexagon has 6 sides. An octagon has 8 sides, right? Octagon. A triangle has 3 sides. So attribute number 2 just means the number of sides. How many sides do you have, right? Okay, that's the first one. Number 2. So pause the video here. And if this part is confusing you, just erase it. We're going to do it tomorrow anyways, so just leave it. So that's number 2. And then now let's move on to number 3 and number 4. We're going to do those together. Okay, number 3. Is the number of faces and vertices, okay? So now their singular form is vertex. So if I only have one vertex, we say vertex. If I have more than one corner, we'll talk about that in a moment, is vertices, okay? Okay. So now let's review what a face and vertex is. Like I said, you should remember that from grade 5, but maybe you have forgotten. So let's do a 2D shape first, and then we'll do a 3D shape. So let's do a 2D triangle first. Okay. And then we'll do the face, how many faces this has, and how many vertex, or vertices I should say. Okay, this triangle right now, how many faces? Now think of face is just, if I'm looking at a piece of paper, let me grab, okay. If I'm looking at a piece of paper, now this is obviously, it's not 2D, but if I'm looking at a piece of paper, think of the face like what it faces you, right? It's just, think of it like you can touch it with your palm, right? So in this case, it's a 2D shape. So there's only one face. So 2D shapes will always, always, always just have one face. That's an easy way to think of it. They're not 3D. There is no shape to it. It's just the board, or it's just my notebook. It's just literally, the face of it has no attribute, right? It's just one. So there's only one face. And then vertices is just all the corners. So how many corners? So vertex, and you definitely should remember this from grade 3 and grade 4. Vertex or vertices are any place where 2 lines meet, okay? Vertices, I'll repeat that again, are any place where 2 lines meet. So in this case, this is a vertex because these 2 lines have met. This is a vertex, 2 lines have met. And this is a vertex, these 2 lines have met. So there are 3 vertices, right? If I had, and let me erase this and do it again. If I had something like that, maybe like a broken triangle, right? How many faces is there? There's none because it's not a shape, right? And how many vertices are there, right? None of the lines can connect. So for us to have a face and for us to have a vertex is when 2 lines meet, any 2 lines meet, okay? To create a corner. A good way to think of it is like a little corner, right? The corner of your room, right? There 2 lines, not 2 walls, but 2 lines had to meet to create a corner. That's like the corner of a shape. That's where 2 lines had to come together to make a vertex. Now let's do a 3D shape, because that's where it gets a little bit more, it's always easy, right? Face is always 1, right? So if I did, let's do square. Okay, again, face, vertices. So how many faces, how many can I touch with my palm? How many faces are there? Is just 1. How many vertices? Where are the corners? And I drew this a little bit crooked. Where are the corners? Where are the places where 2 lines meet? There's 1, there's 2, there's 3, there's 4. So there's 4 vertices. Okay, does that make sense? So face is just the actual face of the shape. And like I said, 2D shapes will always just have one face. And then vertices are any places where two lines meet to create a little corner. That's called a vertex, or if it's more than one, it's vertices. Okay, that's a vertex, 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 vertex. When I say plural, it's 4 vertices. We don't say 4 vertexes, right? It's 4 vertices, okay? That is for a 2D shape. Now let's do the same thing. Let's keep doing faces and vertices, but with a 3D shape, okay? Erase this. And we are going to look at 3D shapes later this unit, so you do need to get ready for that. So let me say, okay. Now you've got grid paper, so use that to the best of your ability. I know some of us get really, really panicked when they can't draw perfect 3D shapes, but do your best. Okay, so draw, okay, first, maybe just follow me. So draw a square first, okay? Then 2 diagonal lines behind. Then, well, yeah, and then we can do this one first. That one, so kind of going like that. Then you connect this, connect that. Now, that's a 3D shape, that's a cube, right? But I'm going to draw as if I can see through it. So right now I can't see through it, but I know as if it was hollow, right? Now you can see the shape. That says it's hollow. Do your best. I know some of us get really, really panicked when we can't draw it. It's okay. When I give you practice sheets, I won't ask you to draw. I'll ask you to just look at it and try your best. And if I do ask you to draw it, I won't mark your ability to draw it. Okay, so don't worry, don't panic, just try your best. So that is a cube. Okay, and I'm actually going to, one second. I want to get something that looks like a cube. Here, one second. Let me go grab that. Actually, yeah. Oh, perfect. I do have a perfect cube. Okay, so I've got a cube. It's this like beautiful, cute little gift I had gotten for my sister. But it's like a love dice. But yeah, it's just a sweet little quote. I'll give you the quote for today. Live well, laugh often, love much. Okay, that's the quote for the day. Okay, so that's basically this. I've got a real life 3D version of this. Now, faces. So if we recap, a 2D shape only has one shape, but a 3D shape will always have more than one. For sure, there will always be more than one. This one, so I'm going to put it over here, and I want you to count. So let's look, you're looking at the heart, okay? How many faces are there? So there's the top one, so that's 1. The bottom one, which is 2, right? So that's 1, 2. Then there's 3, 4, 5, 6. There's 6 faces here, right? So remember, again, there's always one at the top, one at the bottom. So that's already 2, top, bottom. And then there's 4 on the side. So there are 6 faces. Now, if you're having trouble seeing that, then grab something in your home that is a cube shape like this, or even like even if it's not perfectly, like even if I have this book, right? It's a rectangular prism, but again, there's one at the top, one at the bottom, and I'll keep it straight. So one at the top, one at the bottom, and then there's 4 on the sides, right? So every novel that you read has 6 faces. All your math textbook, right? It has 6 faces, the top, the bottom, and then the 4 sides, right? That's 6 faces. So this cube or rectangular prism will have 6 faces, right? So 1, 2, 3, 4, top, bottom. There's always a top, bottom, and then how many ever on the side. So there are 6 faces. Now, vertices, where are all the places that create a corner or where they meet? So let's look at this one. I'm going to hold it again so you can see the heart. That doesn't move for you. Now, where are all the corners? So I see, if I just tilt a little forward, I see there's 1, 2, 3, 4. That's 4 already on the top. So those 4 already done. And then there's 5, 6, 7, 8 at the bottom. So there's 8 corners here, right? In a 3D shape. And I can show you here, there's 1, 2, 3, 4, 5, 6, 7, 8. Okay? So this is easier to see the corners on my board, but sometimes to see the faces, it's nice to have something in front of you. So 6 faces, right? 6 times I can feel with my palm. And then vertices are any 2 places where lines meet, or I have 8 corners, okay? Again, this should be a review from grade 4. You've done tons of this in grade 4. Should have done tons of this in grade 4. Let's do another one. Let me do a triangular prism. And I don't think I have anything in the shape of a triangular prism here. No? Okay, let's do a rectangular prism. So I've got my rectangle. Yeah. Okay, we're going to go slide, slide, this way. Okay, and then I'm going to do the back. You can't see. Okay, that's my 3D rectangular prism. So again, and maybe I'll grab a book this time, or here, I'll grab this. Okay, I've got a box, just any box. It's a rectangular shape. So that's my box, and it's a rectangular prism. So again, I'm going to keep it like this maybe. Now, how many faces are there? So there's always the top, that's 1. The bottom, that's 2. So right now I'm touching 2 faces, right? 1 is the bottom, 1 is the top. That's 2 sides, 2 faces, right? 1, 2. Then there's 1 in the front, 3, 4, 5, and 1 in the back, 6. There are 6 sides to this rectangular prism. 6 sides or 6 faces. Okay, now how many vertices? So again, I'm going to hold it like this. There's 1, 2, 3, 4, and then there's 4 at the bottom, right? 1, 2, 3, 4. That means there are 8 vertices. So there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 vertices. Hope that makes sense. Maybe we'll do one more. Let's do a triangular prism. And then we're done. And you'll have some practice in your Edmodo folder. So imagine like, It's going to be really hard to draw, but I'm going to try. Okay, there's a triangular prism. So again, I don't have anything in my home that is a triangular prism, I think. Yeah, I don't think so. But imagine a triangle that I've taken and I've added 3 sides to it. So how many sides are there? Okay, so I've got that front side, right? The one that you can see in the front. Then there's this one back, and then there's one at the back, and then there's one at the bottom. So there's really 4 faces or 4 sides. I really wish I had something. I don't think I do. But maybe that could be your goal for today, to try to maybe look around your home. Is there any triangular shaped 3D object that you have that kind of, or maybe if you think of like, I was gonna say like Eiffel Tower, but that doesn't help you because it's not a perfect triangle, but there are 3 sides, right? 1, 2, 3, and 1 at the bottom. Now, obviously, if we were in school, we have, and I'm sure in grade 4, so I know they do that because I know Miss Dawn and Miss Ema did it last year. We bring 3D shapes, we practice with shapes. We're not in school, so I can't show you in shapes. So really try. Definitely, you have rectangular prisms at home to check out. Look around. Maybe you do have something that's in the shape of a triangular prism. Okay, so there's 4 faces, and there's 3 obviously because it says triangle, and then there's 1 at the bottom. Okay, how many vertices? So there's 1, 2, 3, 4. So this one has 4 faces and 4 vertices. Okay, so that's all for today. I want you to review the different attributes. So the length of the side, so which ones match? Are they the same length or are they different lengths? 2, which was looking at what was my number 2? The number of sides, yeah, the easy one. How many sides are there? So this one has, well, how many sides does this have, right? This has sides we've done faces. Yeah, we've done the same faces. And then how many vertices and how many faces, okay? So please review that on your Edmodo folder. You'll have some practice questions, and then, yeah, that's about it. Let me know if you have any questions. Like I said, hopefully this is not like brand new information. It really, really shouldn't be. We've done tons of this in grade 4. And I know Miss Donna did tons of it. I know Miss Emer does tons of it. So I'm not too worried about the kids that have been here in the previous year. So this shouldn't be brand new information. If it is, then you've got to definitely maybe rewatch this video and go over it again, okay? And I'll post some practice questions. And that's about it. So have a lovely day, and I'll see you guys soon. Bye.